I recently attended the Nightfall Star Party in Borrego Springs, California, and set up next to me was a father and his adult son, Cliff and Matthew. And talking with them, they showed me the 8-inch SCT they had purchased used, and Matthew mentioned to me that they had also gotten with that SCT this video camera called Revolution Imager 2. And unfortunately, Matthew pointed out that they were unable to get the camera to work at all. They couldn't see anything, and they wanted to use it so they could see more of the deep sky objects and share those views with family and friends. Now, that's not surprising that they had difficulty. That seems to be a very common problem. And why is that? Well, one of the biggest problems with these video cameras is that they're actually security cameras, and they get repurposed, and they do work well for astronomy, but the menus in these things don't make any sense if you're an astronomer. They're not written for astronomy, they're written as a security camera. So I spent about a half an hour with Cliff and Matthew, and I walked them through both the setup of the camera itself, giving them some tips on how to make sure that they were better able to find and locate objects, and also walked them through the menu and showed them that despite the fact there's a lot of things in the menu, there's really only 3 things that you need to change on the fly, and most of the rest you can completely ignore, or at least ignore until you become very familiar with the camera. So today I want to go through that once again on video, and hopefully other people out there like Matthew and Cliff who have cameras like these and just don't know how to use them will see this video, and it'll help them get started. And I'd like to say that that evening Matthew and Cliff really went through a lot of deep sky objects, from galaxies to nebula to star clusters, and actually were very excited and thankful that they finally got it to work. And of course, that actually made the trip for me. I was quite happy to be able to help them out. So let me go through some of the same things I went through with Cliff and Matthew and see if that helps you out. So the Revolution Imager comes with the camera itself, which you can see is fairly small form factor camera. The camera has a video output. This uses what's called a BNC type connector, or a bayonet connector, and it has a 5.5 by 2.1 millimeter power input. It has a power on light, LED light, and it has 5 buttons on the back that are used to control the on-screen menu. Which is very difficult to do in the dark, especially when the telescope changes direction. It's hard to remember which way is which. That's why they also supply one of these UTC controllers. UTC stands for up the cable. And so this simply plugs into the back of the camera, and then you can use this to go up, down, left, right, and select for the menu, and we'll go through that later. So this is very convenient. The camera also comes with a C-mount nose piece, so when this gets screwed on the front end, then this enables this to attach to the back of the telescope just like an eyepiece. And this particular one is a split ring, so it can be changed in its length, which is useful when using the focal reducer. The other thing that's very difficult for people when they get started is if they're using something like that Schmidt-Cassegrain at f10, that 8-inch Schmidt-Cassegrain at f10 is 2,000 millimeters in focal length. Well, the chip inside these things is relatively small. It's about 6 millimeters across in diagonal, which makes this equivalent to a 6 millimeter focal length eyepiece. So if you divide 2,000 by 6, the magnification at the native focal length is going to be over 333. It's way too high of magnification when you're starting out to try and find things, because it's very easy to get lost. You may be out of focus, you may be on it and you can't tell you're there, you may be close but not there. So typically in EAA, people work between f5 and f6. So something like their Schmidt-Cassegrain, it's nice that the Revolution Imager also comes with one of these 0.5 focal reducers. So this will attach to the front of this C-mount adapter, and it'll also slide right into the eyepiece holder, and that'll reduce the focal length from f10 down to f2, or the focal ratio from f10 down to f2, and the focal length from 2000 down to 1000. So it'll give you a better chance of finding things, gives you a wider field of view. That also shortens the exposure time needed to actually see something, which is another good thing to do when you're first starting out. Now, if you have a refractor that is running at f6, you don't necessarily need a focal reducer. You can use one. If you have an imaging Newtonian, those things are probably f5 or less, f4, and you're okay without the focal reducer there because you already have a fast optical system. The other thing that the Revolution Imager comes with is one of these little LCD monitors. It has a red plug for DC input and the yellow one for the video input from the camera, and then has menu controls on the front screen. Revolution Imager is also supplied with one of these lithium polymer batteries. I really don't like these, the lithium polymer batteries. This one, which you can't see, is puffed up, which means the polymer package inside is damaged. I need to get rid of this safely. I prefer these talent cell. If you're going to use something small, I prefer the talent cell lithium batteries. These use cylindrical batteries, not pouch cells like the one in that one. They come in all different sizes and price ranges. This is an 8 amp hour 12 volt output battery with a recharger. This thing is a little bit, definitely heavier, but it'll last longer, and it's I think it's a lot safer to use. And it'll supply power for, you know, the mount as well as the camera and everything else for an extended period of time. You will also get a splitter cable for the power. So the power comes in here, and it'll go out both to the camera here and also go to the input on the display here. And then you put the power from the power supply into here. And it will come also with a video cable. Now my cable is a little different. I don't have the original video cable that goes with this, but it'll be a bayonet mount type on this side, and then it will have a RCA jack output on this side. In my case, this is a straight BNC to BNC connector, so I use one of these adapters, which is BNC male to RCA male, and it goes on this end, twists in, and then this will plug into the video input on this side. Like I said, the original cables that come with this, you don't need this adapter. It's already built in. So that's what the camera comes with. So let's go through some of the tips on getting started. All right, so let's talk about how to set this up. So first, you remove the cover, the plastic cover from the camera, and you install both pieces of the C-mount adapter. And you're going to want to do that because then you put in your focal reducer so that you get a 0.5 reduction in the focal length of your telescope. So if you have an Schmidt-Cassegrain natively at f10, that'll bring you down to f5, which will speed up the camera, give you a bigger field of view, make it easier to find objects. If you already have an imaging Newtonian, then you're probably f5 or better. You won't need the focal reducer. And if you have a refractor, say f6 or so, you may not want to use the focal reducer. As you get more experience, you can split the C-mount adapter and move the focal reducer closer, attach it to the smaller piece. That will speed up the imaging of the camera for shorter exposures, but it'll also cause vignetting and distortion because this focal reducer is actually designed to be a certain distance away. You move it too close, you do get a wider field of view, but then the light rays aren't coming in the way they should and things get distorted. So start like this. Now on an equatorial mounted telescope, get rid of the diagonal and stick this right at the back of the telescope. No extra optics in the way. But with something like this Alt-Az mount, if I were to do that, this thing might bang into the base of the mount, and there wouldn't be room even then for the cables that come out the back. So if you have a setup like this Alt-Az mount, you'll want to keep the focal reducer, and you'll put the camera in there, tighten it up. Now, when I do public outreach, I've got some Velcro here, or 3M strips, and I've mounted my camera here. Even though this battery is no good, I'm just using this as an example. Put the battery up here, and you'll want to play around with the routing of the cables to make it as nice looking and least likely to cause a problem as possible. You will need the power splitter to come off of the battery, and then I think I can go this way. I can put power into the camera and also put power into the display. And the last one is going to be the video connections. So we're going to want to use this UTC hand controller, and we're going to want to mount that on the back. So we attach, as I said, this is not the original video cable. I lost mine somewhere, but this works fine. This has got the BNC on one end, and it has an RCA jack on the other. And then this just attaches here to the video out. If I get it lined up. There we go. And it locks in. And then this will attach over here. Do some cable management. This is, if I were going out to outreach, I would like to tidy up the cables. But now you have the power to the monitor, the power to the camera, you have the video out, and then you can start, put power onto the camera. We'll show you that up close, and then you can start using the hand control to run through the procedure. So what I told Matthew was start during the day. If you have the ability to see a distant object like a tree or a power pole, start with that. Point the telescope at that object, get the camera going, and try to get an image and get it in focus. Because the biggest problems are you have a very small field of view with this 6mm diameter chip. And if you're out of focus, you might actually be on the object and not be able to tell. You could be on a bright star, you can be on Jupiter, and it's so out of focus, the light is spread out so much you can't tell where you are. And if you think you can eyeball stuff, it's harder than you think. It's even hard to point the telescope at the full moon and actually get it in the field of the view by trial and error. So do it during the day if at all possible, which is what Matthew did. He got the focus where he needed it on a very distant object. He got his first view through the camera on the display of a distant tree, and everything looked good. And then when the nightfall came, he was ready to start, and he started with Jupiter, and he was able to see the bands on Jupiter, and from there he went on through the rest of the evening. So let me then take you through the menu, which is the most confusing part of this for most people, but hopefully I can make it simple, because I'm telling you, there's really only 3 things you need to pay attention to on the menu. All the rest, you can set it and forget it, and in most cases just leave it to what it was set at when the camera came to you. So let's take a look at that now. As I said before, the thing that trips people up the most with these analog video cameras is the menu, and that's because the menu is designed with the functions for a security camera, and so it doesn't really translate that easily for astronomy. But let's go through the menu, and then I see if I can help you understand which items are important, which ones you can ignore. First, I have the camera on, but I have a cover over the lens. So we're not going to see any deep sky objects here. This way we can just focus on the actual menu items. To get the menu up, you press the center button on the back of the camera or on the hand control, and there you see the first page of the menu. So the first question is, how do you navigate through the menu? You can use the up, down, left, right arrows. So if I press the down arrow, I can scroll down through each function in the menu. A nice feature, if I get to the bottom and hit the down arrow again, it will come back to the top. So it'll cycle through. And if you use the up arrow, you can move in the other direction. Some of the modern hand controls don't have a down arrow, so you can just use the up arrow to scroll through the settings. So what it's telling us here is we're on the main page number 1 of 2 main pages. And let's use the right arrow to move to main page number 2. And this is a good point at which to say there's nothing here that you need to touch, change, or worry about. So let's go back to the main page number 1 by using the left arrow. All right, we'll go through these one by one. The first function here is called Scene Select, and this is going to be one of the most important places that we will spend our time when viewing the night sky. But before I go into that, let me go through the other ones below first. Hit the down arrow, and this item here is called Picture Adjust, and you see the right angle arrow. That means that if you click the center button, you will bring up more options for picture adjustment. And as you can see, this allows you to adjust the display, brightness, contrast, sharpness, and so forth, which you can also adjust most likely on the monitor or display that you're looking at, but you can do it here within the camera as well. Now I would suggest you start with these settings and not worry too much about this when you first get started. But if you do want to play with these, you just scroll through them. So for brightness, if I right click and I bring it up, I want you to notice that it takes some time for the camera to make the adjustment, and then you see the impact to the adjustments in the brightness. And so what this is doing is it is increasing the background brightness. So the level that you set this to will depend on the quality of your night skies. If your skies are very light polluted, you're going to want to keep this down. If you are at a very dark site, you might be able to bring this brightness up. The other setting of interest that I want to mention, sharpness. That will determine how crisp the boundaries in deep sky objects and nebula and things like that will be. I like setting a 5. You try that out. If you go too high in sharpness, the image will look like an artifact. It won't look realistic. So that's something you might want to play with. But I suggest on the first night out, start with these settings and maybe just leave them alone unless you have some reason to believe you need to bring up the brightness or drop the brightness. So if we hit the return button by pressing the center key, we come back to this main page number 1. The next item, which is of interest to us, is an electronic zoom. This enables us to increase the magnification. Right now it's off. If I right click, it will be turned on, and you can see the angled arrow tells us there are some options. So the electronic zoom allows us to magnify the image, and you would do that by increasing this number here. Since we're just looking at a blank background, you can't really see the effect of magnification. So let me set that back. Pan and tilt allow you to rotate and move the object on the screen, so you can position it where you want. The magnification, I think, is useful, but in the beginning you should start with it off. Next is DIS. That stands for Digital Image Stabilization. This is of no use to us for astronomy. It's there for the security camera in case it is in a windy environment where it would be vibrating, shaking, and so the software will try to adjust the image so it stabilizes it. If we've got the vibration and shaking at using a telescope, we're going to have more serious problems. So that should stay off. Privacy mask should stay off. Well, there's no on-off. You'd have to set the privacy mask by going into this, and this is of no use for us in astronomy. This blocks out an area of the image so that it is not visible on the monitor. So say your security camera is looking over some neighbor's window or something, you can block that off. Motion detect is also strictly for security cameras. This is used to detect motion, send the signal to a video recorder if the camera is connected to the video recorder. So you don't record hours of nothing and only turn on the recorder when there is some activity. And system settings. Let's take a look at system settings by pressing the center button. And there's a few things you might be interested in here. First, sync mode. There's no option here. There's a single camera. It will be internally synced. If you had multiple security cameras, then there would be options here how to sync the cameras. Lens assumes that you have a security camera with some sort of lens on the front. We don't. We have a telescope, so just leave this alone. Flip is nice. As you probably know, not all telescopes will give you the image in the true up, down, left, right orientation. Some will flip the image upside down, some will flip left to right, and some will do both, depending on what kind of telescope you have. This will let you correct that. So if I right-click, it will flip the image vertically. If I click in it again, it'll flip the image horizontally. And if I click one more time, it'll flip the image both horizontally and vertically. So this is something that you might want to use, but you would just set it and forget it for your typical telescope setup. We turn that off for now. Next is an option to tell the video circuitry how to optimize the output. If you're using an LCD display, which most people would be, or an OLED display, you would use the LCD. If you're old school and using a cathode ray tube, you right click and you see a slight shift in the background of the image, and this would optimize the output for a CRT. And again, this would be set it and forget it unless you change monitors. Communication, you are not going to play with. I just quick show you. There's a lot of things in here. You don't want to mess this up. Just leave it alone. And camera ID is off. I typically leave it off. Let's right click to turn it on and take a look what's in here. So this lets you put an ID or a set of characters or words or phrases on screen that'll overlap whatever the image is. So if you were looking at M33, the Galaxy M33, and you were doing something like public outreach and you wanted people to know, hey, this is M33, you could go through this process here selecting the characters. It's rather tedious. You can even move the position of where the characters are, and then you return. And if you return and leave this on when you exit the menu, it'll say M33 in the upper left-hand corner. In general, you'll leave this off, especially when you first get started. So on the first night out, you don't need to play with anything other than adjust this to what you're using. Maybe you want to flip the image vertically or horizontally. Other than that, leave everything alone, and if you set anything here, you just set it and you're done. So let's return. So on this first page, there's very little that you will adjust on the fly, other than maybe the brightness, contrast, sharpness. So that leaves us with Scene Select, which is actually the most important function on this page. Now there are several options for Scene Select. I'll right click, you see Full Auto. This allows the camera to adjust the settings for the scene. There's indoor. You can imagine with the security camera, it will adjust things differently for indoor, outdoor. If it's a backlit image, I'm not sure what ITS is. But you can forget about all of those. You want to use the custom scene select because it gives you the maximum ability to adjust things optimally for astronomy. So let's just use custom. So if I click the center button, that brings us onto this subpages. There are two subpages here, 1 and 2. So let's right click and go to 2 because we can quickly realize these are all things that are used for security camera applications and are not useful for astronomy. So the first one is a compensation for shaded lens. So sometimes you see these security cameras that have shrouds around them and the corners of the image might be in shadows or shade. You would turn this on to correct for that. The next, defog. If you're looking in foggy conditions, this will adjust the image to try to make it better. If we have fog, we're not probably doing astronomy. Flickless is there to compensate for some screen flickering. And then the anti-CR is anti-color roll, and that's an effect when you're shooting an image in a with fluorescent lighting, so which we're not going to do. So there's nothing on this page that you need to worry about. So left click and go back. So under custom, this is where you will spend your time. And the first and most important is the adjustment of the exposure and the camera gain. So the shutter speed or exposure and the automatic gain control. And there are 3 options here: fixed, auto, and you see something just happened to the background. The camera adjusted exposure and gain, even though we're just looking at a end cap on the camera. And you see it got noisy. And then there's manual. So let's take a look at manual. Manual allows you to adjust the shutter speed, and it lets you set a maximum gain. The camera will not exceed that gain, but it may set the gain lower than the number I have on the screen. But it will use your shutter speed. So you get to adjust the exposure time, but not exactly adjust the gain. Just set the maximum when you're in manual. When you're in auto, it will control the exposure and the gain itself. It'll determine what it thinks is best. And you might think that was the best thing to do when you're just starting out, but that really is not the case. What you want to use is fixed. So, and you see, it took a while for it to adjust for auto. The background was noisy. Then when I went to fixed, the background quieted down because of the settings that we'll see here on fixed. So for the exposure and the gain, I recommend you start with fixed. Now we're on the minimum exposure time, or the fastest shutter speed, which is 1/10,000th of a second. That's good for the sun, perhaps the moon. If you're looking at a full moon, you'll probably use a neutral density filter, because even 1/10,000th of a second, it'll probably blow out the image. And if you're looking at the sun, of course, you'll put filters on your telescope. And all right, so this is the shortest exposure, 1/10,000th of a second. If I left click, you can see we're increasing the exposure, 1/1000th of a second, and so on. When you get all the way up here to 1/50th of a second. Now these particular exposures are good for things, as I said, like the sun, the moon, and the planets. Depending on the night sky conditions, you'll select which one you want. For deep sky objects, you want to go for a longer exposure than 1/50th of a second. So if I left click again, you see the format changes. So this is now 2/50th of a second, even though it doesn't say 2/50. This is just the way they format this and the convention they use in these cameras. So it goes 2/50ths, 4, 8, and so on, all the way up to 256/50ths of a second. So divide 256 by 50 and you get 5.1 0.12 seconds. This is the maximum exposure time for a single frame with the Revolution Imager 2. And I'm going to recommend that you start somewhere between 128, which is half that, or just a little over 2.6 seconds, and 256. And that will depend on how dark your skies are. But if you want to bring in a very dim deep sky object, you're going to need a longer exposure time. So somewhere in this range is a good place to start. Now you see, if you look, all of a sudden those are not stars. Those are warm pixels in my camera. Since I'm not looking at anything, they show up pretty well. If I drop the shutter speed to a shorter exposure time, those things will go away. You see they're going away. It takes a little time, once again, for the camera to actually make the adjustment. If I bring it back up, you'll see they start to come back. All right, so start somewhere in here, 128, 256, and then gain. The automatic gain control just boosts the signal electronically. This is the lowest gain, 6 dB. You can go up in increments, and then this is the maximum, 44.8. And if we wait a moment here, you'll see I get more warm pixels, and you start to see some more noise in the background. So when you increase the gain, so here's a tremendous amount of noise because we're not really looking at anything. And you see a lot of green. You'll see the red and the blue. More green because there are 2 green pixels for every red and every blue pixel. So you'll seldom be able to go this high in gain unless you're really dark skies and no light pollution. So I would say you probably want to start somewhere around 24 dB. You may need to go lower if you have bright skies. You may be able to go a little higher if your skies are very dark. While the gain will boost the image, it'll also boost the noise. So you have to be careful here. It's a trade-off. So that's the fixed settings, and that's where you will spend the majority of your time working on those two. As you go to object, you'll want to make adjustments in those so you can bring out the most detail depending on the size, brightness of the object, where in the sky it's pointing, and what kind of light pollution you have. So let's go down to the next function, white balance. This allows the camera to adjust the basic color, and you want to work on this initially, and then once you get it where you like it, you probably want to leave it alone for a while. So there are several different adjustments here. The one I would recommend you focus on is the user, and there's 2 of them, user 1, user 2, and they're basically the same, but you can set it up for one type of object on user 1, and you can optimize it for another type of object. So nebula might be one setting, and galaxies might be another. So user 1, user 2 will be the same. If I click the center button, you see this will allow you to adjust the gain on the blue channel and the gain on the red channel. Once you do that, then everything is determined. You don't have a gain adjustment on the green channel. So you would do this by going to an object of interest, something that has some color in it, and some large nebula or so. Or you can go to a galaxy, which should be mostly white, and you can adjust these levels and select between blue and red and adjust the gains. These might be interesting places for you to start, just to see what you get. Now, the white balance, I think you're just going to set it once in the evening, and you may need to make adjustments on subsequent nights for the differences in sky conditions, but you won't be changing this frequently on the fly like you will the exposure in the gain. If we go down 1, the next set of functions are called HLC, which is highlight compensation, and BLC, backlight compensation. These can be useful for astronomy objects, but I suggest you start with these in the off position and forget about them until you become very familiar with all of the other settings that you need to adjust. but let's go through them anyway. So suppose you have a bright object in the foreground and dimmer stuff in the background. Well, you're going to be overexposed if you set the exposure to high enough to bring out the object in the background, because the foreground object will overexpose. So what this will do is it will diminish the intensity of the bright object in the foreground, so you don't overexpose or underexpose the background object. So right click to turn it on, and highlight compensation does have a level, and you would play with this level to see what works best. If I right click again, there's a backlight compensation, and it doesn't have any adjustments. It's either on or off. And backlight compensation is used when you have a bright light or object behind the subject. So think of a DSLR camera and you take a picture of someone, a portrait of someone, but the sun's behind them. You have a bright sun in the background, they're going to be in the shadows. So what a backlight compensation will do is it will adjust the exposure to bring out the foreground object so it's not in shadows. And like I said, I would start with these off and only start to investigate these once you get some experience with a number of deep sky objects using the most important settings. Next is something called adaptive tone reproduction. This is useful when you have both bright and dark areas in the same image. And this actually can be used for astronomy applications as well, because we often will have light and dark objects. So this will improve contrast in those cases. If you turn it on, you see you have some contrast adjustment, mid, high, and low, right? So they're set here. And clear face, I'm not really sure clear face what that is, to be honest with you, but it also has a mid-high and a low adjustment. So this can be something of interest to astronomy, same as this one, but in both cases I would start with them off. That brings us to the next very important function in these security cameras, which is digital noise reduction. What this does, it allows you to take multiple frames and average the information from one frame to the next. So if I select this, you'll see you can set the level up to 6 frames. So let's suppose I set it for 6 frames. What happens? And let's suppose I'm using 256 for my exposure. The camera will take an image at 5.12 seconds, and then you'll see it displayed on the screen. And most likely you'll see a noisy background, and you won't be able to see as much detail as you really would like to see, but you'll see something. Well, then the camera takes a second image, and when it takes the second image, it will average the information from those 2 images, and that will basically improve the signal to noise. The background noise is going to be random, so it won't be the same from image to image, so that tends to average out. But the signal will be the same from image to image, and that will then be more detail will be brought out in the image. And when you get to the 3rd frame, even more detail, 4th, 5th, 6th frame, you'll get even more detail. Now, if you leave this on and you continue, the camera will take a 7th frame, and it will discard the 1st frame and just use the 2nd through 7th frames, and so on and so on. So depending on where you have this set, so if I had this set at 6 and I'm using 256 for my exposure setting, that will take 6 times 5.12 seconds, which is just under 31 seconds. And you have to keep in mind, if you're on an Alt-Az mount, you may not be able to get exposures beyond 30 seconds without getting significant star trailing, because the Alt-Az mount is not really tracking the Earth's rotation. So you may have to back off on the number of frames. Maybe you only use 4, or you'll have to back off on the exposure. Maybe you don't use 256, you use 128. But in either case, this DNR is a very important function, and one that you will want to continue to use throughout the evening. And you make adjustments depending on your sky conditions, just like the shutter speed and the gain. And also, if you're on an Alt-Az mount, depending on where you are in the night sky, how many images you can average before you start to see star trailing and things look like eggs instead of round objects. The next one is day-night. And you might think, well, I'm out at night, I want this to be on at night. Well, you want it to be set to day if you want color. If I set it, right-click, set it to night, you will see that this thing will switch to black and white, and you will not see anything in color. Now, there's nothing wrong with that. Sometimes it's more interesting to look at an object in black and white and ignore the color. So you can switch between day and night if you want to go between color and black and white. And then there's some more detail here. There's this burst, which is basically on-off. And to be honest with you, I have never played with the burst, but I have gone to the night setting to put things into black and white. And if you notice, when you go to day to night, the IR optimizer turns to the point where you actually can turn something on here, and there's some IR optimization. So the assumption here is the security camera is sensitive in the IR, which is why we use these for astronomy. So if you turned on the night setting, then you can do some adjustments here for the image, which is going to be recorded in the infrared. So it'll be black and white with a lot of signal from the infrared. So leave this in the day mode for now and look at the objects in black and white. Okay, so to summarize, there's nothing on this page 2 that you will work with. You will spend your time mostly here with the exposure and the gain. I recommend using fixed for maximum control, and you will also be toggling this on and off depending on where you are looking through the night sky. So you'll mostly be going between these two here and here, in my experience. You can try these things later in time as you get more experienced, and you will want to set up the white balance the first time to get the colors to look realistic from your perspective. Let's go back to the top. And so there you have it. Now, when you have made your adjustments to your settings, of course, the object will be visible behind this menu. So the menu will overlay on the object. You don't want that to be the case once you're satisfied with the settings. So you'll go here to exit, and if you hit save, it'll clear the screen and it'll save all the changes you made. If you decide I don't want to save those changes, you use the next one and it'll clear the screen, go off, exit the menu, and it will not have changed any of the settings from what you had originally. And if you hit cancel, it'll kick you out of the menu as well and cancel any changes you made. Back will throw you back into the menu. So when you're done, you typically will say save, and then it'll clear the screen, and then you are looking at the night sky. So the next thing we need to do is actually look at a night sky object and make some of those adjustments and see how it works. All right, so in this part of the video, we're going to do an actual demonstration on a deep sky object using the elements of the menu that I talked about before. So I'm using the 6-inch SCT with a 0.5 focal reducer on the camera, everything that I showed you at the very beginning of this video. I've gone ahead and focused and aligned the mount. I'm using an Alt-Az mount, so I can't expect it to track with the Earth's rotation very well, but it will do a reasonable job with the short exposures we're going to look at. And I've already be aligned to the Orion Nebula. Now I picked the Orion Nebula because it's an easy target, it's very colorful, and it'll help demonstrate some of the menu settings. So I'm at a very short exposure. You can see the trapezium, the 4 stars in the center with some nebulosity around it. You can see the 3 stars in the belt. So let's bring up the menu. Let's go to custom and let's go into the exposure. So you see I'm at 8/50ths of a second. Let's bring that up. As I bring it up, you see the nebulosity begin to appear. Bring it up to the max, 256, which is 5.12 seconds. And so now you can see a lot more nebulosity. And if I get out of the way here, so now you can see the entire image. Now one disadvantage of the Revolution Imager 2 among the other analog cameras is it is a very small chip. It's a 1/3 inch, which means it's about 6 millimeters diagonal. So you're really zooming in on things here. And it's hard to fit a lot of big objects in the field of view. But anyway, there's the image. You can see some sky background. I'm in a fairly light polluted area just east of the San Francisco Bay area. So let's bring the menu back up, go back into custom, go back into the exposure and the gain. Let's see what happens when we bring the gain up. Let's bring it up a couple of notches and you'll see why I had the gain set down low as the camera catches up. There you go. Now you see in the extremities a lot more nebulosity that you couldn't see before. You'll also see a lot of graininess in the background due to the gain. That's one disadvantage of the gain. And you also see that the core is completely blown out. So this is why with these sky conditions I'm using the lowest gain possible. Now if I were at a dark site with very dark skies, I could probably run up the gain, like I said before, somewhere between 24 and 30 at a very dark site. So another thing we can play with is the digital noise reduction. I told you these 3 things, the shutter, the gain, and the DNR are the most commonly manipulated things when you're doing observing. So let's bring this up to 3. And what this will do is it will average the signal from 3 successive images, and it'll keep scrolling through. When it gets the next one, it'll drop the first one, and the next one will drop the second one. It'll just continually average 3 frames. And so what this should do is clean up the background a bit, and it enables it to enhance the image by cleaning up the noise and leaving the signal. If you go all the way up to 6, that will take almost 31 full seconds, and depending on where you're looking in the night sky with an Alt-Az mount, that may be too long of an exposure to avoid seeing elongated stars or star trailing. Now if you're on an equatorial mount and you're polar aligned, you won't have any problem. So what this is doing is it's averaging over 6 successive frames, each 5.12 seconds. So if this were too long, I could drop the exposure down, or I could drop the number of frames down. Now what I would do in this case is just drop the number of frames down. So you do see a little bit of star movement there. Let's drop the number of frames down. And actually, let's get there quickly. So this will just bring us back to a single frame. And I don't want to have to wait 15, 16 seconds. And then I can bring this up to 3. and start averaging over 3 frames. And there's no timer here, so you kind of have to figure the 15 seconds yourself. Alright, so that's the digital noise reduction. I'm turning that off. Let's go down here. The other thing we can play with is the white balance. So I have this set. You can see that the nebulosity is fairly red. If I drop it down, drop the red gain down, see what happens. Now it's getting less red and more blue. Now it's really purple now with a bluish green in the middle. That doesn't look pretty realistic to what I have seen from this nebula, and you're free to pick whatever set of colors works best for you, but you can kind of see what's going on here, right? So I adjusted the red gain. You could play with the blue gain. You can play with these things to make them look however you want them to look. Another thing is day night. So let's go to black and white by clicking night, and I'm gonna move all this stuff off the screen. And so there's what the nebula looks like in black and white. All right, let's go back and bring back the color. There we go. Back to day. Now the menu will come back to color fairly quickly, but the image will take some time to come back. So I'll zoom ahead rather than waste time here, but it does take a fair amount of time. For the color back, I don't know why this camera does that. I haven't seen that in other analog cameras, switching from day to night. That took, almost a full minute to get the color back. Now, another thing we can do is, instead of doing the fixed, let's let this thing do auto, and I'll show you why I don't like auto. Remember, auto, it adjusts the exposure and the gain to what it thinks are the best. Now that's obviously it's increased the gain significantly. It's blown out the core, and then all the nebulosity has all this graininess in it. So I would not recommend auto, even though it would seem to a beginner that that's like the best place to be. We can go back to this page 1, and we can look at the brightness contrast. So let's increase the brightness and see how that behaves. So the background is getting to be too light. So where I am, that's too high. So that's why I have it down lower. Another important one is the sharpness. So let me run the sharpness way up, and then you can see what happens here. Let me clear this out. So you see what happened. You've got artifacts around the stars. You've got these black rings around the stars, and even the nebula itself that looks kind of creepy. So this is not what we want, and that's why I say maybe start with the sharpness around 5. And let's see, this will bring this back. There you go, cleaned it up. Let's go the other extreme. Let's bring it all the way down. And so it's not sharp at all. It actually looks kind of out of focus. So that's also not a good setting from my perspective. And so in most cases I find 5 to be pleasing for me. You'll figure out what works for you. And I think that's probably all that I want to show here for these settings for the Orion Nebula. For the sake of time, I've inserted images of 3 deep sky objects I was also able to view using this same setup with a Revolution Imager 2. The first one is the globular cluster M13, then the ring nebula M57, and finally the whirlpool galaxy M51. I've also added examples of 6 different deep sky objects I was able to view with the Revolution Imager 2 on the 6-inch SCT at a dark site. And you can see from these images that you can see a whole lot more with this camera, even with the 6-inch SCT out at a dark site. So I hope that gives you an idea of what you can see in a dark place. So that's pretty much everything I wanted to cover in this tutorial on the Revolution Imager 2. I hope this helps you have more enjoyable nights under the sky with this camera instead of frustration. Please like the video if you found it helpful. And if you want to view additional videos I have made and will make on astronomy, astronomy equipment, and astronomy techniques, you can subscribe to this channel. And of course, you can find more content as well on my website, californiaskies.com. Thank you for watching.